Hello, my name is Brendan Enrick, and I'd like to welcome you to DevChatter Basics. In this episode, we're discussing enums in C#. I'll be explaining what they are, how they work, and some tricks to keep in mind while using them. Whether you've been using the language for years, or are just starting with it, a good foundation of the basics can help improve your code. Get comfortable as we learn about enums. We usually say enum, but that's just a shorter way of describing an enumerated type. You don't hear that name very often, huh? Well, enum is shorter and avoids a lot of confusion that you could get in the language with enumerators and enumerables, which are, yes, two different things from enumerated types. As the word type implies here, these are data types in C#, which means we learned a little bit about these in our DevChatter Basics video about types in C#. Stick with us, though, because we'll be diving in a little further into enums today. As a type, what makes enum special is that the type will have a named set of values. In this way, we can imagine many sets of things that could exist and have enums for them. Take this set of named values. If we had a seasons enumeration, it might have these four values: winter, spring, summer, and fall, or autumn if you prefer. If we were to create an enum using C#, it might look something like this. The definition for this enum looks a lot like a class or struct in C#. It's a structure common to the type definitions. So you'll notice an access modifier, the keyword enum, and the name of the enum. Inside the type, we can see each of our named values in the set: winter, spring, summer, and fall. As a general guideline, which I'll explain why later, I recommend intentionally choosing the order of your enum. Some sets might have a linear or circular order to them. Seasons cycle through, so any could have been chosen as the first in the set, but the order is still the same. We've been talking about enums for a bit already, but I still haven't really answered what are enums. We said that they're a named set of values, sure, but what kind of values? And the answer to that is they're numbers. Enums are just sets of named number values. They let you have a name for a specific, and sometimes unknown, number value. And for us in C#, numbers will default to integers. If you don't specify the type of your enum, it will be an integer as the underlying type. We can, however, define an enum to be any of the underlying value number types that we want. For example, we could choose to have an enum that was a ushort. To define our enum as one of those other types, we just add the name of the underlying type to the definition. Notice that the syntax looks very similar to how we define inheritance or an interface implementation in C#, by following our type name with a colon and the type we want to inherit from. While enums aren't exactly inheriting from integer or short, it is defining the underlying type of the values in our set, so it is quite similar still. In this example, we're using a ushort, which is a 16-bit unsigned integer. Our int type that we use so often in C# is a 32-bit signed integer. Learning more about those is a topic for another episode. In addition to changing the underlying type, we can also specify the values of the set, giving us control of the values we want for the enum. This is especially important if we want these values to be stored in some kind of a data store like a database, or even if they're already in a data store with specific values somewhere, it's even more important. Specifying these values ensures that the values don't change unless someone intentionally changes them. I mentioned previously to intentionally choose the order of the values in your enum. Let's talk about why. In this example, we specify the value of only the first item in the set. Behind the scenes, C# will assign a value to each of these with ascending values for each item in the set. When I do this, I often set the first item to a value of 1, so that it doesn't start with 0, which would be the normal default. Since C# is automatically assigning values to the items in the enum, it used the default of the number type, which was 0. I prefer avoiding 0 as my unintended default value for an enum and have it start as 1. This helps avoid incoming data of 0, which is an unassigned value in C#, being interpreted as a valid value in my seasons enum. You might ask why I don't specify each item in the set. Well, if it's going to be stored somewhere, I do set each value. But if it's not going to be stored and I just want it to not start at 0, then I usually do this because I don't care what the values are. We started this off by saying that the items in an enum are just names for values. It would make sense that we could get that value from them. To do that, we can just cast them as the underlying value type we want instead, as you can see in this code. I do recommend using the enum itself most of the time, but there will be occasions when you need the value instead of the enum. Sometimes we receive only the underlying value, so we need to get the enum from that value. Since the enum is just a name for that value, we can cast as it directly as well. At this point, you might have a question forming in the back of your mind. What would happen if the value in the variable isn't among the named values of the enum? As shocking as it is, the cast works just fine, and we get an instance of our enum that doesn't match any of the named values in our set. While receiving a variable that matches none of the set may be a problem sometimes, it can also be useful, which is one of the reasons why the language allows it. That, however, is a topic that we'll explain in a future episode. For now, we just want to make sure that you've got that warning. Let's go ahead and talk next about strings. So getting the value of the enum is nice, but if you saw the number 2, would you know which season it corresponded to? I wouldn't know either. This is one of the many reasons one might want to show the name instead of the value of an item from the set. As developers in the code, we will see the name rather than the value, but the executing program will obviously be working with the value. There will be times where we need to display the enum to a user. If we're not careful, it will display the value, but we likely want to show them the name if it's anything where the user might see or even be able to interact with. For example, we might show it in a URL. We obviously aren't expecting our users to hand edit these URLs. However, it's nice if they can see it as the name rather than the value. This will help them confirm that they're in the right place. If they bookmark the page, it's obvious what they've bookmarked if we're showing nice names instead of a series of cryptic numbers to them. For our URL example, a controller in ASP.NET Core would provide the enum from that name if you ask for it. But what if you're not in that scenario and you have to get the enum from the string on your own? In that case, you'd need to parse it from the string. When we parse an enum from a string, we use the static parse method on the system.enum type. It's one of the older methods in the system libraries and hasn't seen much change since the early days of .NET. So it isn't using generics. Instead, we're passing in the type we want to parse. The type of method will provide the information for the seasons enum to the method. Then we're passing in the text, and the type that it returns is just an object. So we'll have to cast it as our enum. Many of us aren't used to these old ways of coding in C#, so we wrap this in an extension method that will provide a nicer way of working with it that we're more used to, instead of these static methods from the C# of old. So don't worry if this looks confusing. This is the method I would use to wrap it, since this will offer a convenient way of parsing any enum I need If you aren't familiar with extension methods, you can watch our DevChatter Basics video about extension methods, or you can just follow along. We won't go too far off of our enum focus here. To avoid losing anyone, though, the keyword this here is what makes our method, a static method, into an extension method. We won't pass the string argument the traditional way, though. You'll see when we show an example of calling this. Also in this code, these angle brackets indicate that we've made the method generic, so our enum type will be specified by the caller. When the DevChatter Basics video on generics exists, I'll link it here as well as I did with the extension methods one. The code I'm using here is for C# 7.3 or newer, since this line restricts the generic so that it has an enum type constraint. Constraining to an enum is a relatively recent addition to the language, and the code in the method is the same code we saw previously, and you're probably wondering now what it would look like to call this method. I don't know about you, but I think that this looks a lot nicer than what we had before. So how about doing the reverse? What if we have an item from the enum and want to get its name as a string instead? Well, there are a couple of ways that we can go. If you know which item you need at the time you're writing the code, you can use the name of method, which in this case will just give us the text fall as a string. It will just do a compile time replacement of this, so no work is done while running the code. Sometimes we won't know what the specific one we want is until we run the program. In those cases, we'll have a variable and we'll do this instead. The easiest way, and the way I'd recommend in nearly every circumstance, is just to call the toString method on the enum directly. In our example here, we'll get winter as a string. Underneath the hood, this is just calling a complex-looking static method similar to the one we saw when parsing. If you really want to be explicit, you could make your own extension method there as well. For example, you could make a toName method, and it would be called like this. Most people are used to seeing toString on these, so you don't really need to do this. But for those who are so inclined, you can add an extension method. And this is an example of an implementation of a toName method. I just want to note here that I've implemented it using the call to the static method I alluded to earlier. This is the complex version that is also called by toString. As we try to keep these videos short, I might not have covered the enum-related topic you were looking for. If that's the case, stay tuned as I plan to cover some additional enum-related topics in other DevChatter videos. Thanks for learning about enums with us. Join our DevChatter live coding streams on Twitch at twitch.tv/devchatter. If you enjoyed this DevChatter Basics video, be sure to click the like button and subscribe to catch all of our future episodes. Happy coding!